Record. Cool. Yeah, so welcome to the working group multi-tenancy. And we're going to be discussing a doc from Christian and Let's.
Yeah, Lutz, you want to start? Or?
I'll go ahead. First of all, I'm very sorry about the mess with the link and generally the short notice. But Christian and I to separate the functionality that our GitLab integration does today into some part that we think would be for general use in handling a tenant abstraction within the cluster, and provide at least a concept of how to integrate that with external resources or external components that would set those labels, names, identifiers that need to be controlled in a business conforming manner. I hope you had the chance to have at least a look at the document. And so we basically sat down and said, okay, we need a tenancy that defines information about a tenant, and tried to do this as lightweight as possible. And we were looking for, or we are looking for input on use cases that may or may not be covered with the mechanics that are sketched out here. If I should I go through the ideas step by step? Is that okay?
I think so. I'm not sure everyone had a chance to read it, so that would probably be a good idea.
Yeah.
I just had one comment. Can you sort of expand on why namespaces are not viable for this while you're discussing it? I know that's in the doc, but I think that would be helpful.
Yeah. I'm not actually quite sure on when we decided that, but early on we just established that a single tenant may have multiple namespaces. I think one of the most common use cases for that is one tenant creates a multi-level app, a three-layer app, whatever, and expose only resources from one namespace via the ingress, and have network isolation, network security with something like Canal or similar between individual namespaces. So that tenant by itself would require more than one namespace. We also have a use case, simply map external entities, basically projects in GitLab, GitHub, whatever you use, to individual namespaces, because that was the best fit we could see, and we stuck with that. I think the discussions, or as far as I've understood, the discussions in the last couple of weeks, that basic path of one tenant having possibly more than one namespace. And if that doesn't fit your local model, then you can always simply add one namespace to the tenant object, but for instance, add multiple users that may access that namespace. Does that answer your question?
Yeah, somewhat. Yes. Since other people haven't read the doc, I don't want to jump straight into comments if you still have sort of exposition about the proposal itself.
Okay, well, we can get back to that later. Okay, the idea is basically that a tenant is granted certain resources, a certain resource quota, resource budget, whatever you want to call it. At the moment, we choose the most simple one that we could think of implementing, which is a simple number to the concurrent amount of resources across all namespaces. So you have, let's say, a budget of 5 cores. That means you can have, as a 5 cores in operation with all your pods across all your namespaces. More complex things like budgeting over time, like you get 1,000 core minutes or whatever, or core hours, would be an extension to that initial proposal. And in order to minimize the thing change, we thought that any resources in those namespaces named in the list of namespaces of a given tenant will be accounted towards this total. So if tenant A has namespace 1 and 2, whoever the permission or the capability to add resources in those namespaces, they will be charged to tenant A, regardless whether it was let's say an administrator that had the powers to do so, or one of the users that is basically assigned to the tenants. The user assignment is optional. So basically you need to have a list of namespaces for accounting purposes or for quota calculation purposes. And then in addition to that, a list of usernames and the roles they should have are set in the tenant CRD, and the controller will then set up those RBACs by simply binding or by attempting to bind the named roles to those users with a just standard role binding. And yeah, that's the basic idea.
So it's basically like a hierarchy, but just fixed at 2 levels. And is that right?
Yes, I wouldn't consider it a hierarchy, but yes, basically it is. Yeah, that's true. I don't see the need for more tiers. So yes, it is a hierarchy, but I wouldn't
So you see it as more of just a way of grouping namespaces together into disjoint sets, basically.
Yeah.
Yeah, we see it for that, and also to separate to sort of do a separation of concerns here, like that the organizational structures are different of what you can actually define in the cluster with the RBAC and role bindings and that kinds. So we figured that it would be nice to have something at the translation adapter that actually takes whatever you have as your organizational source of truth and then translate this into a tenant object, which is more idiomatic for your organizational needs, and then can from there be picked up by a tenant controller that then translates that to whatever mechanisms we have in Kubernetes to actually make it work in the cluster, like role bindings and like RBAC, and also like all these possibilities to restrict and quote resources. That was the second part of the idea that we need this handoff thing, because currently the GitLab integration project we have, it's working, but it's doing a lot of things, and it's also very opinionated about the way it does it. So we thought we would like to separate these two things, like what do we take from our GitLab side in that case, or from our source of truth, and what do we make of the results in the cluster? So that was also an architectural kind of thing that we wanted to do. And yeah, I might add that the other thing that we need in order to make this work ultimately is a tenant resource quota admission controller, which basically is an extension to the already present quota admission controller, in that sense that it counts the quota across multiple namespaces and maps that to a tenant, and then applies the restriction. That's the other thing that we need to do in the end.
Are you letting tenants, individual users, create namespaces?
I'm sorry, can you repeat this?
Are you letting individual users create namespaces here?
Yeah, we do that in a moment by letting them create projects and stuff in GitLab, so they can create namespaces through kubectl or on the cluster itself, but they can simply create a project, a group, or whatever in GitLab. So that automatically creates a namespace for them. Yeah.
So because there's a lot more that you need for multi-tenancy, and this was talked a lot about in the last sort of session where we went through, I think it was Atlassian's multi-tenant setup, that you need stuff like pod security policies, network policy, resource quota, RBAC. Like you need to set all of those up for an individual namespace before you go and let anyone access it at all. So rather than an admission controller, why wouldn't you just create those on behalf of the user and then give them access post hoc? Because even if you restrict like the quota for a particular namespace, if they can create a namespace and then it doesn't have a pod security policy set up, then you're giving them more access than you expected.
I think no, this is a misunderstanding. The power they have for creating spaces is via a separate mechanism, and all the prerequisites would then be part of the list of things that the tenant controller would have to do. Pod security and it's not yet fleshed out in the document, but yes, I have to go back through the recording from 2 weeks ago and add that to the laundry list of things that the controller should do.
So the idea then is that in that case where you set it all up for them, you have to sort of pick quotas on a per namespace and say like, this user controls namespace A and namespace B, but I'm going to give them individual quotas in those ones. Whereas you would like a mechanism to say namespace A and namespace B contribute both to one singular quota that then has a limit together.
Exactly.
Yeah, the latter one. So at the moment, just to clarify, we have this GitLab integrator, and that does all the stuff with the pod security policies and etc. So it creates a namespace and then sets up stuff just like pod security policies, and only binds people to roles that are predefined. And you can provide these role names to the service via environment variables, so they can you as the admin have control about what they can actually do in the namespaces, and we lock them in rather tightly so they can do their stuff in the namespaces, and they can self-service, create namespaces, but they can't break out or do weird things with it or exceed certain limits, etc. Yeah, and we just want to translate this into multiple projects to make them more feasible to be reused and re-engineered that a bit towards a more nicely architectured solution. Yeah.
I have a quick question.
Go ahead.
Can you go over again, what was the reasoning behind allowing multiple namespaces per tenant? It had something to do with the ingress.
No, not the ingress per se, but users to set up applications with multiple namespaces. For instance, for separating tiers of a multi-tier application. For us, it's more of a resource management problem, because we have organizational units that we want to give the ability to create, to basically organize themselves internally, but they have to be constrained into a certain resource budget. It basically boils down to one organizational unit is able to procure a certain amount of money for computational resources, and they should be able to use these resources just provided through us. But how they organize with projects and groups and subgroups, that's up to them, and we don't even want to interfere with that. That was the idea, but on the end we have to group all their resource uses together to conform to the amount of computational resources they have bought. That's the basic idea. And all the controls or controllers and admission controllers that are there now always focus on the namespace, and a single namespace is a too small unit for us.
Thanks.
Do you see this extending to all of the policy objects, all of the types, or just quota? Or you mentioned quota and RBAC, or like what is your thought there?
Yeah, sorry. Yes, it's. We have a list of things that we've learned to have a requirement for limiting for individual users or individual tenants, and that's not just cores in memory, but also request rate. The number of objects, for instance, is something that we have to monitor closely because we have a fairly low node count. So 130 pods per node for us is something that is threatening. At the moment, we can live with that, but that's becoming a problem soon. So, what did I say? How many nodes we have, Christian?
You just said a fairly low count, and I just thought I add some numbers to it.
Yeah. Users, so that's and some of them actually go ahead and try to create as many pods as they can, which is our job to stop them.
Yeah, so we need to have security measures. So we need to make sure they don't break out of the pods. Like on the node level, we have to have pod security policies in place. We will ultimately have to have like network policies. We have the quotas, RBAC, and then we have what else do we have? Policies, network policies, yeah.
Well,
And what we need is the API count. We really have trouble with the control plane, and that people can just hammer that, and we don't have a way at the moment to really restrict just how many API calls per minute or something like that people can make. So that will be something that would ease up our lives in the near future. So the whole multi-tenancy in the control plane idea is something that's also pretty important for us.
I have a question regarding quota. As I understand, your controller is doing resource quota on group of namespaces. In that scenario, are you still using quota on namespace level when you are having resource quota on group of namespaces?
No, we can't, because that would require people to decide how to move their resources between namespaces. And we would have to enable them to do that, actually. So that's just not feasible. We also have this thing where people just work together and use their resources together. And then the question is, if you start something in another namespace, does this get reduced from your quota or from the quota of somebody else who also belongs to that namespace? Do your quotas add up somehow? So we thought the easiest thing and the most straightforward thing to design that was to say, okay, we have one tenant, and that is linked, that has resources, and that is linked to a namespace, and whatever happens in that namespace is reduced from, or is taken from the quota for the resources from that tenant. So that's why.
Yeah, exactly. Actually, that's why I asked that question, because when we are doing quota on group of namespaces, I think doing quota on namespace might have some conflict. Yeah. So I think it's better not to do quota on namespace, just to have quota on that group of namespace.
Oh, okay.
Yeah, thank you.
So Christian and Lutz, in the document you talk a lot about different types of kind of bring your own pool of compute. How does that tie into what you're talking about here with the sort of a tenancy quota?
You're referring to bring your own computers, bring your own devices, and that kind of stuff.
No, so I mean, like you're talking about sort of organizations being able to supply the nodes to add to the cluster, is what I mean. Sorry.
Yeah, we are a university, and we have different research projects, and they get grant money, and from that they buy resources, which is then essentially nodes for computing basically anything. So there can be anything from just casual compute nodes to data science nodes to GPU nodes or to some kind of a sensory network nodes for IoT stuff or whatever you can come up with. The main reason we want to restrict, or the easiest reason why we want to restrict that is because they have the notion that from an organizational point of view, we as the lab have to provide some kind of service that they can place their money in and then get a simplified access to that resources to reduce ramp-up times for research and that kind of stuff. And our way, or we hope that we can do that through finding a way that we can say, okay, we buy resources or we take your resources and add them to the cluster, and we have a way to provide you with exclusive access to that resources. And we then also thought, okay, if we can do that, then we can also democratize resources so that if people don't use the resources at the moment, then they can be used by other people, which is what we refer to as the sharing and the leasing of resources that we want to enable. That's sort of due to the way that we operate, that we have these distinct research projects where people, they might not even know each other, but they basically all want the same in that case. And that's why I think it would be very feasible to allow them to just add these to the cluster and then have access to their own resources when they want it and do whatever they want on that, and then can also share that with others if they don't need it at the moment.
In real life, often they don't actually buy the resources, or we try to teach them not to actually buy resources, compute nodes, but give the money directly to us. But on paper, it's still their node. We operate that for them.
There's a somewhat related or relevant project called it's not exactly the same model as we were talking about here, but called the Cube Arbitrator, that kind of expresses quotas as minimum guarantees instead of maximums, and that's a way that like the unused resources in the cluster can be fairly shared among the different users of the cluster. And so it's kind of one way at getting at this idea of borrowing. You're not directly borrowing because they didn't. Well, it's sort of like borrowing, let's say. So you might want to look into that just as a comparison point for that. I realize that that's kind of just one piece of this like possible future work thing that you listed here and isn't integral to the rest of this proposal, but it's something you might want to look into because it's just as a reference point, because it's kind of related to that idea of borrowing quota from other users.
I quickly with that the aggregated document. What is, I'm not sure if it makes us special, but we usually have a problem with users not being able to manage their own clusters. So all this node leasing and sharing is just a business exercise, if you like. Technically, we have to do the actual setting up of nodes and maintaining the cluster. But I'll have a further look into the aggregate.
Yeah, it's not based on the idea of people kind of owning nodes at that, and then lending those out. It's more about the quota and the system giving people kind of a minimum guarantee and then being able to share all the unused resources as a pool. It's kind of related to the model that Mesos uses. But anyway, yeah, it's worth checking out. But yeah, it's done nothing.
I'm a little unclear about the scenario about updating the namespaces in a tenant. So according to my understanding, so if you want to add a namespace, they should update this a tenant custom resource. So that means a user in the namespace can basically update the tenant custom resource, and he has a full control of all the namespaces defined in this resource. That means he may be able to delete a certain namespace that he doesn't belong to. So is there any fine-grained control over the privilege that user can touch other people's namespace, but they are both in the same tenant?
No, and we don't see the need for that, because one, we would envision that the tenant objects are maintained by an external source of truth, and in addition to that, we would set up RBAC rules that only basically the cluster admin would be able to manipulate the tenant objects anyway. But yes, you're right. If we make rules and any user gets access to those tenant objects, they can do whatever they like. That's right. It boils down to never giving away the access to the tenant objects.
So in general, most of the sort of sysadmin kind of stuff is done by the external controller rather than by the actual users. Is that what you're saying?
Yes, but it's even more restricted. That's why we present this document to see other or to learn of other use cases. I can't envision a use case where anybody but this maintenance system or the master admin gets access to the tenant objects anyway. So it's more of a technical necessity to actually have this access available at all than a regular use case.
I guess what I meant was it feels like it's important to have the understanding that when you talk about the tenant making changes, you're talking about the tenant making changes via, in your case, changing GitLab that then has a controller make the changes rather than the tenant making API changes directly.
Correct.
Yeah, I guess I asked the question earlier about the bringing your own the pools of compute because we have a similar issue in our multi-tenant, the internal multi-tenant cluster, where we have different CI/CD, or so we have different batch job use cases, and for them we do give them a separate pool of nodes. So we have a slightly similar use case in some ways, but we do that in a very coarse-grained way at the moment with taints and tolerations. So we taint all the nodes with customer equals this customer, and then that customer can then tolerate those taints with their pods, and only their stuff will run on there. There's 100% no guarantees about that, and that is 100% based on trust at the moment, rather than based on hard enforcing things.
But how do you? There's two questions to that for me. How do you taint these nodes? I mean, do you do that manually, or is there some kind of automatism? And the second one is how do you communicate the required tolerations to the customers?
So in our case, we've only got a couple of customers, so the communication part is easy. We say, hey, to run your builds on your nodes, you need to have this toleration using this config standard. Done, easy. And the regards to actually tainting the nodes, it's just part of the node config when you start up the kubelet. The kubelets start up with this taint. That's it.
Okay.
As I said, it's very coarse-grained and simple at the moment because it was the quickest, easiest way we could solve that problem.
Yeah, we are just wondering if anybody else out there is in the need of such a fine-grained and an automated way of setting up stuff in a cluster, because we found a lot of things that work similar but didn't quite suit our needs. And I'm not quite sure if you're very special in that, or as a university especially, or if there is anybody else.
So are you saying that the controller that creates the namespaces in a tenant environment, that's not controlled by the tenant themselves, that's controlled by something else?
Yes.
And then what is the type of thing that kicks off creating that namespace?
It's an action that is done at the moment in an external system that is controlled by the company or by the organization that you're in. And there the user has some interface that he or she can understand and is just used to use. Like creating a project in GitLab, that is one thing.
But they have control over what the namespace is named?
Yes.
Okay.
I mean, to the extent that the name of the project is part of the name in the namespace, at the moment at least.
So it sounds like if it's tied to GitLab projects, it's the GitLab itself is sort of what's making sure that there are no namespaces overlapping. Is that correct?
No, in that case, it's actually the integrator that does have a look if a names. I mean, what we do is we take the path name out of GitLab because you also have groups and subgroups in that special case. So you get a name and you then translate that to a valid KLS name. And the integrator also checks for an already present namespace by the same name. And if so, just counts up and makes sure you don't have the clash or collisions. It doesn't delete an already present namespace by the same name. To prevent that somebody creates a project called Cube System or something, and then you end up with no Cube System anymore.
Okay.
But I mean, it sounds like the integrator has some kind of access control rules built into it that are separate from Kubernetes RBAC that are deciding what operations different users are allowed to do on different namespaces. Is that right?
What you do is the integrator requires you to provide the names of roles that you map to the roles that GitLab provides, like a guest, developer, master, etc. And you have to provide these names, and you have to provide the roles or the role definitions in Kubernetes. And then these get used to map the users according to the role level in the project. So for instance, a master in a project in GitLab gets mapped to a role that allows that master to actually start nodes and to delete, start pods and to delete pods. And of course, read the logs, etc. They are not allowed to run daemon sets. That's a special thing that we only allow to certain people. And all the other roles, like developer, guest, etc., they are only allowed to read logs and see what's there and just see what's running in the namespaces that are referenced to the projects they're a part of. So that's what we do right now. But you would be free to say, okay, in my case, a developer might also create pods or throw them away or whatever. So by that, we also give out the possibility within the bounds of the rules and of the role settings that we provide in the cluster, so that users may decide based on GitLab who may actually alter the stuff in the namespace. So they can change that by themselves by changing the level of access in GitLab, and that gets automatically done and then mapped to the cluster.
And all this setting up and applying GitLab roles to Kubernetes rules is part of the opinionated flavor of the integrator right now, and is one of the things we want to break up and reduce with this controller proposal. And that one more point with namespaces, that's the mapping from an external name to a valid and unique namespace name that is mentioned in the document, where the tenant object can have arbitrary bias for namespaces as they would be introduced by the external system, and then some mapping component that would create the valid Kubernetes systems, which is right now, as Christian explained, done by this simply numbering or increasing a number after a somewhat valid name that we use. And we want to switch that out for something that's better understood or more generic in capabilities.
Anything else anyone wanted to discuss, or I don't know?
So are you guys going to have an open source project at some point, or?
The whole thing is open source. I mean, it's all on GitHub, the stuff that we already built, which is this this custom GitLab integration thing, and in its current state, I'm not quite satisfied with it anymore because it's doing too many things. We have a Greylog integration because we were looking into multi-tenant solutions for logging, which were quite sparse in case of open source solutions. The whole, I wanted to link it. The integrator is here. Let me see. Here's the link. And yeah, it's just in a state where it works for us. I think it's quite configurable. But we really want to take this on the next level to be more feasible to be reused and to be extended, maybe.
Which is basically the intent of this document, to get comments and to get feedback on map to your own use cases, or if you can come up with a use case that could fit with minimal extensions or similar or something like that. And the end result definitely would be an open source project, yes.
So I was reading the document. Hi, I'm Ray, and I joined late, but I was reading the document, and I noticed there wasn't really a motivations section. And maybe that gets to the use cases, but I would love to see that in terms of the use cases. And then the other thing I'd love to understand is what scale do you see this working at? Do you see this working with like 50 namespaces? Do you know, if clusters have 1,000 namespaces, you know, at what level does this is most effective? All right.
What we have right now is, I mean, the doc is from like 4 hours ago, so we just thought we'd write it up, and because we had it in our minds for the whole time, and just bring it in. So it's very early, maybe too early to share here. I don't know, but we will definitely add the motivation section. And to give you some numbers, at the moment we run the integrator thing on a cluster that has right now 1,200 namespaces, I think, and 11,000 role bindings. And today we ran 2,400 pods, etc. So that's
and how many people control that cluster? Like how many folks are involved? Like real people are involved in those?
You mean like how many people use it, or like how many people do actually administer?
How many people are actually authorized? How many people are authorized to make changes? Like when it comes to these kind of policy administrations, I find it useful to think about not just the sheer number of namespaces, because sometimes we create them programmatically for stuff, but it really comes down to the amount of people who are involved in the management of this, right? So if a cluster represents 1,000 developers, right, then that's a different thing than if a cluster represents 100 developers or 10 developers, right? And then the type of policy administration you need varies depending on those, the human scale, right?
Yeah, I think in the past half year we had around 200 people that were actually doing stuff in the cluster. Yeah, organized different projects. Some were in multiple projects, which adds this up to multiple namespaces that they control or that they do stuff in. And now we have the holiday season at the moment in the university. we have gained some new research people. So yeah, I'd say all in all, we had like 200 people over the past 5 to 6 months.
Okay. Yeah, because
simultaneously maybe 120, like at the same time doing stuff.
Cool. And I think this gets to the motivation. When I hear 200, I see one level of hierarchy being okay, right? When you get to 2000, I think it's probably not going to be okay, right? Maybe, right? And so I would love to think about that in this thing, right? If we do a solution like this, would it make sense to just do n, right? Rather than just one, because there are a lot of different shops out there that would love to use this, and some of them are big, right? And we don't want to forget our friends over there. Right. So, yeah.
Where would you see these additional levels of hierarchy? I'm not quite sure what element you are afraid will not scale.
So I think when you start to think about, like, quota, for example, right? If in your proposal you have 2 levels of quota, which makes a lot of sense, right? So you have like the actual namespace, and then you might have this like tenant, and then the tenant has quota on it, right? And when you think about that, and you start thinking of 2,000 developers, those developers are going to be organized into teams, right? But they're also going to be organized into products, and then they're also going to be organized into probably like areas, right? And when you're a cluster admin and you're thinking about 200 teams, let's say, right? It gets to be a lot of work to go and individually modify the quota of each. And so you might want to delegate that to a quota admin who sits at the top of, let's say 300 developers, and say, you go deal with them, right? And that's a popular thing. We do it inside of Google all the time, right? We can't scale to our scale, but even when I was, we talk to people who have 3,000 developers, they have the same problems.
So you're saying that rather than build n equals 2, you should build either n equals 1 or n equals arbitrary number.
That's right, because at n equals 1, you can start to do things like, well, I'll just go ahead and build that outside in some CI/CD system, and then I'll compile that and then push the quotas in, and then I'll make my changes in the outside system, right? And that's kind of where people are today, right? Or you want to fully represent it, right? And do, you could do n levels, and then you don't have to put it outside, you can put it inside. Right. And then developers get a nicer experience because they actually get to see all the levels, right? They don't have to worry about, oh, I got quota denied. It turns out the other system knows why I got denied, and it doesn't, they don't know inside of Kube. Right. So I don't know.
I'm actually not quite sure if the whole, we found a number of small things that add up if you're managing a comparatively high number of users on a cluster with our less than 50 nodes. And actually, I don't have confidence to scale our model up to, let's say, 2,000 concurrently active power users, simply because of managing stuff like the size of the etcd. And I think going full multi-level, this tenant thing and on the quota computation will add a lot of computational overhead. It would be great. I mean, don't take me wrong. It is definitely a goal to aspire to. But with all the details that haven't quite worked as we expected, sure if that is a good idea. And the question is if the user experience wouldn't be better actually if you have this external system. And we actually always envisioned to have this external system for self-service, if for nothing else, to set up the quotas.
So I think if I heard your argument right, you're saying that basically it's pretty compute intensive to be able to do arbitrary levels of hierarchy, and it's much simpler to do just 2, right? And that Kubernetes isn't generally scaled at that level anyways, such that you would have this high parallelism. Is that my understanding of what you just said? I just want to make sure I got it right.
Yes, the scaling. I'm not sure. It may not have simply it is not such a path. but our experience is that Kubernetes does not scale as well for many users on a low number of nodes as it does for high node counts.
Yeah, so I'm making the assumption that these are high node count clusters, right? When you start getting up into like the big users, right? You want to have big clusters, right? But this thing you're proposing should work for both, I would hope, right?
I don't know. It's beyond my experience.
Okay.
It's
Well,
as simple as that. We have less than 50 clusters. It's nothing more than our
nodes.
Yeah.
Sorry, less than 50 nodes. It's nothing more than our limited scope of experience.
Yeah, so all I'm saying is that there are folks out there who want big clusters and have big clusters, right? And they would love this too, right? And they would love to get the benefit from it. So it would be cool to see us do it. And then the other thing I would say is that the levels of hierarchy is probably not going to go much above 4. Just in the experience I've seen, I know at Google we don't go above 4, and we're giant. There are like 40,000 people who interact with our systems, right? So you're not talking a ton of levels, but it's just when you get into 2 versus n, right? N is really less than 7 or 8, right? It's so that's my thinking. I would love to see this thing kind of work for these large cases, which I care passionately about, right? So
I'll have it.
Did you guys get a chance to look at Quentin's hierarchical labels doc at all, or
Yes.
Okay. How do you see that, if that happens, how do you guys see this fitting in?
I'm not sure. I see the hierarchical labels as a tool to do hierarchical stuff for whatever, and it would allow, for instance, grant parts of the cluster to certain groups or subgroups of users simply by controlling the subtrees of the labels via RBAC. But the mechanical interaction between a label hierarchy and quota computation or quota management, I'm not sure yet.
just to add a little bit about that, on that document, I asked some questions to Quentin, for example, like how you deal with multiple inheritance, right? So, things like when you assign quota, if you assign it in a label type thing, how do you prevent someone from, for example, assigning one label to have 30 CPUs and another one from assigning 10 CPUs, right? And then how do you resolve that? Is it 20 CPUs? Is it 30? Is it 10? Is it 40? Right? And I think that proposal really has to think a lot about explainability, so that people understand where they're at. And what I like about this proposal here is that because it's hierarchical, it's very easy for people to tell how they got their stuff. So, I think customers, when the admins, they're going to want to be able to answer those questions for them to feel comfortable using something like Quentin's proposal.
Yeah, so I think there's 2 ways of interpreting that question. One was Quentin's proposal, like in a literal sense, and then the other is if Kubernetes is going to have some kind of hierarchy, whether it's expressed in the way Quentin described with the kind of hierarchical labels or a more explicit hierarchy, or however it's done. If we're going to have hierarchy for more than 2 levels, should a system like this be designed with that in mind from the get-go? Right. And so I would think the answer to that is yes, regardless of whether the way hierarchy comes to Kubernetes is something like what Quentin described or some other approach. Although, none of this has been decided. So it's a little speculative to base one speculative system on another speculative decision. It's like speculative turtles all the way down, but I think it is a relevant question if you broaden it out to, like, if Kubernetes is going to have hierarchy with multiple levels in general, should this proposal that we're talking about today take that into account?
There was one other thing that was kind of touched on in one of the documents, which is the difference between a tree and a DAG representation. I mean, structures. But I think you guys really need the graph, don't you?
Is this a question about whether a namespace can be in more than one tenant in this proposal that we're talking about?
So with the labels one of the proposals was just like prefix matching, which really only works for a tree. You can't have, leaves can't be members of multiple branches. But I don't think that meets some people's requirements.
Can you give an example? I'm not completely clear what you're getting at.
Users might be members of multiple teams.
So you're saying a namespace could belong to more than one tenant? Is that what you're saying?
Yeah. So our use case isn't that right now, but I got the impression from Lutz and Christian that theirs is. So yeah. So yeah, things lower down can have multiple parents.
Our use case definitely does that because people can be basically members in any of the tenants. And just a side note, every person is a tenant to himself or to herself for that. But the single level abstraction that we choose avoids any problems with that, because the users are not separate objects. It's just the tenants have the resources, and some entities are allowed to consume them, but they're not charged to the user. They're charged, and the namespace then are collected and aggregated to the tenant. Sorry.
And one other thing to consider on the thing is that with RBAC, with group support, you actually can use groups to represent your users, right? And apply them across namespaces, right? And so it's really a separation between identities and who has access to what and the resources in their organization, right? And I think you can get pretty far with that kind of approach.
We'll think about it.
Yeah, I think there's lots of stuff to think about, and maybe also point out more clearly in the doc, like the motivation, the quantities, maybe the levels, and to point out exactly what the use cases are that we want to cover. I think it's pretty important. Yeah, so I think as the time is almost up, or it's up, I personally would like to thank you very much for the insights and the ideas and the hints and the feedback. And I think we'll work on this more towards next time, and we'll see where we get.
Thanks, guys.
Yeah, thank you.
Yeah, thanks very much.
So hopefully next week we'll have Quentin too, and we can go over that one. Yeah, so see you all.